guys, welcome to this video. In this review session we're going to quickly look at input, outputs and variables. So on the screen here we got a completed program, and let's start with our variables up here. So we have our main function starting here, and then we have 3 lines of variable declaration. So like we said before, variable declaration is where a variable is data type and name is defined. In this case we have multiple names separated by comma, so that just means multiple variables, all of the same data type int. Here we have a variable called average of data type float, this floating point, and here we have a variable name called char underscore input of data type char. So just very quickly, it's not allowed to have a space in your name of any variable. So if you do want to have a space, then we put a placeholder of an underscore. Okay, so we have a couple of variables here. You can also see in the commentary to the right, it's described. And with this one, there's something different, and that's the fact that we are actually not only declaring the sum variable, which is an integer variable, but we're also initializing it to the value 0. Initializing is nothing other than writing to the variable, and it's the very first value that it will have. So on the line where you declare, you are also allowed to initialize a variable right there and then. However, after this, you can still go and change the value of a variable should you want to, and you'll see that as for I pretty soon. Alright, so let's move on down into the program. So after our 3 lines of variable declarations, then we get to a printf. So up here, that's just commentary describing what we're doing down here. So it says they capture 3 user integer input values. So we are going to ask the user and capture 3 integer values. So first and foremost, we have a printf, and printf comes from the S3IO library, that's standard input output library. So printf is a function that we use to display a string on the computer console, on the screen basically, and it will display exactly what we have put in between the inverted commas, double quote commas there, double quotes, excuse me. So it will print that highlighted string, that highlighted sentence there, including this space, because that space is part of the string that we are effectively sending to printf, and then printf will go and print that to the screen for us. Right, so that's an output. There you can clearly see an output, and we are making use of the printf function from the S3IO library. Then for an input from the keyboard, we're going to use scanf. And scanf is one of the functions that we use, most commonly used actually, and it's to capture a value specifically from the user's keyboard. And for scanf we need to specify 2 arguments. Okay, first and foremost, once again a string between double quotes, %d, as you can see there. That means we are going to capture an integer value. So that's %d, and I'll show you the others as we go on. Then the second argument is that, so you can see there is a variable value 1. It was declared up here on line 10, and we are using it here to capture input from the keyboard and then store it to that variable. So we're using scanf, technically speaking, we're using scanf, the function, to capture a value from the keyboard, and then scanf will write that value to memory. And how does it do that? By using the variable, because a variable is nothing other than memory space, allocated memory. Please note that you must use an ampersand. When you use scanf, you must use an ampersand symbol immediately in front of your variable name. Okay, very important. It's called the memory address operator, and it's beyond the scope of our subject. But for now, just remember, whenever you use scanf, not printf, just scanf, make sure that you put an ampersand and then the name of the variable. Alright, so they will capture and store the first integer value from the user. Then we're doing something else here. The statement reads, I equal to 2 semicolon. Now we know that that equal to is the assignment operator. It's not really equal to in the sense of mass. Equal to in the sense of mass we know is equal to two double equal to signs, and we'll see that when we get to our selection structures, etc. So what we are doing here is, if you look up here on line 10 again, where we declared our variables, you can see that we've declared an I variable there, integer I, but we did not initialize it. We did not write anything to it, and it's not mandatory, we don't have to. Down here on line 17, we have decided, let's write the value 2 into I. So very important here, the assignment operator executes from right to left. So it reads the value on the right and it writes it to the location on the left. So I, you can read it as I, set I to 2. Okay, so set I to 2. Alright, now we're getting to our second printf. And here we are once again saying enter value, but this time we have a %d, where before we had a 1, here we have a %d. So when you have %d in your string, or %f or %c for the 3 data types that we are working with here, that basically means that you want to insert a value in your string there. And the value of that value must come from another argument. Okay, in this case we only have one %d in our string, so we only need one extra argument beyond the string. So this I, which is our second argument for printf, the value of I will be placed in the string right there at that position %d. Alright, so suppose you had more. Let me just quickly show you here. Let's say we had another %d for whatever reason that we did need it. We would have to list yet another argument, let's say value 1. So what will happen here is that the value stored in the variable value 1 will be placed in the second %d. How do we know which one is which one? It works in order from left to right. So that's the first %d and that's the second. If you evaluate it from left to right, that's the first argument after the string, that's the second argument after the string. So exactly the same order of the %ds, it will be replaced by the order of the variables that we've listed. Okay, so I don't want this change that I've made to apply really, so I'm going to undo that. So here we will say enter value, and then what's going to be placed there? The value of I. And on the line just before it, on line 17, we have set I to 2. So it should print enter value 2. So it's as good as us typing 2 there. The big difference, however, is that when we do it like this, we are reading the value from a variable and inserting it into the string. And that is a very useful thing to be able to do. In this case, it doesn't really make sense, so this is just for illustration purposes at this point. Okay, and then we use a scanf exactly like we did before. It's an integer, so that's %d. However, this time we don't want to write it to the value 1 variable, we want to write it to value 2 variable. Okay, so if we use value 1 variable here again, what simply would happen is the value entered here at the second input will then override the first input that's been previously stored to value 1. So you can only store one value in a variable at any given time. The moment you try to store a second value to a variable, it will simply overwrite the previous one. So you can do it, and it's often done, but then you have to know that whatever value was in your variable, it's going to be gone. Okay, and now we've captured the second input from the user. Now on line 20, we're doing something to I yet again. This time I'm using the incrementation operator. That's the plus that you see there. So basically what that does is it adds 1 to whatever is already stored in I. So a relative command, so it's relative to whatever is in I. So whatever is in I will be incremented by 1. So you can also have done it with that statement, I equals to I plus 1, or you could have done it with this statement, I plus equals to 1. All of them are equivalent. Right, so now we've incremented I from 2, which it was up here. We set it to 2. Here we simply read it. There we just simply read it. We didn't change it or write to it. Now we are reading and writing. Okay, so we're adding 1 to it. So we first, the computer will of course read what is the value of I, add 1 to that, and store that result back into I. So I will be incremented from 2 to 3. So now in this third printf, it will print enter value, then it inserts I there, and that will be 3. So we should get the resultant output of enter value 1, enter value 2, enter value 3. And it's yet deliberately shown to you in different ways so that you can see all the possibilities, or most of the possibilities at least. But in reality, what you probably would have done is that. And then of course remove I there and remove I there. Okay, I'm going to leave it as such so that you can see the results from that. And like I said, that's purely for illustration purposes, so you guys can see that that can be done. And then we obviously capture and store our third integer value from the user, and this time we store it to the variable called value 3. Alright, and that's it for the 3 integer values from the user stored to those first 3 integer variables up to there. Now the next thing we want to do in this program is we would like to go and determine what is the average value of these 3 values. So in order to do that, we need to go and read each and every value in each and every one of these variables that we have used up to now, which is value 1, value 2, and value 3. So there's only one value on them, so we just simply list the variable's name. Then we use the addition operator, list the variable's name, use the addition operator, list the variable's name. And then this result will be taken by the assignment operator and written to this location. I say location because the name of a variable simply actually refers to the location in memory where it's stored. So if you were to read this from left to right, you would say sum is set to value 1 plus value 2 plus value 3. So an answer will be calculated for that first, a result, and that value will then be stored to sum. So once again, the assignment operator executes from right to left. So it first needs a value on the right so that it can write it to the location on the left. And on the next line we have the assignment operator yet again. This time we want to write a value to average. And what we have on the right then, which will be executed first, is we have something funny here. Float in brackets, sum divided by 3. That is, slash is the division operator in C. So we're basically taking sum and we're dividing it by 3, because we know to calculate an average, you divide by the amount of values that were added, and you can see there were 3 values added. The reason why we have this float in the brackets in front of sum is because sum is an integer and 3 is an integer. The division operator will return a result as an integer. And we know when we have a division, you most oftenly have decimal remainder values. So at this point in time, if we did not have that, if we just simply had it like that, C will accept it. The answer that will be calculated will be without any remainder values. So it's not going to be a very accurate answer. So if you do want remainder values to be included, you have to typecast or permanently change. Typecast is a temporary operation, or permanently one of them have to be a floating point value. So if you have a float, let's say sum was a floating point variable, then a float divided by an integer, your answer will be given as a floating point value. In this case, we don't want sum to be an integer value, variable, excuse me. We want it to be a floating point variable, but we still would like to receive an answer to be calculated here with decimal remainders. So one of the things we can do is to typecast sum to a float, because we know it's an int, it's typecast to a float, meaning for this specific operator, this division operator, the sum variable will be treated as a floating point variable. Okay, the data on it will be treated, actually converted temporarily to a floating point value. All right, it's not a permanent thing. Sum is still an integer variable the moment you move past it and the value stored in it. is also still an integer. So this is just a temporary thing. Okay, and then we will get a floating point answer, and that answer will be stored here. Okay, so let's move on. We have our average, and now in this couple of lines down here, these couple of lines here, we would like to go and print out what is the sum total, what is the average, and then we just want to demonstrate that you can move the cursor without printing anything to the screen, and then we start working with floats, which I'll get to in a second. Alright, so let's go and see here. We're saying printf, the sum total is %d. Okay, that's a tab space, that's a new line. Alright, so we're moving it up by a tab and then printing, and then we would like to actually print our value. I see here it's slightly reversed. And then we move to the new line, so we won't really see the effect of that tab, but it doesn't matter at this stage. So we want to see the sum total is, and then the sum total value printed there. So that's why we have %d and sum here. Okay, then printf, the average is, and then we have this. Now we know average is a floating point variable. If we go up here, you'll see on line 11, we declared average to be a floating point variable, because we know that we want to store a floating point value into it. So normally if you want to display a floating point variable, you just say %f, and then you of course list your floating point variable or value. However, in this case, we would like it to be rounded to 2 decimal places after the comma. If you just leave it like this, you will see that it's going to be printed with 6 decimal places after the comma. I just want 2 in this case, so I'll put %.2f. That's just the instruction to round the floating point value to 2 decimal places after the comma or after the dot. Alright, move the cursor to the next line. So we just put a /n there. There's nothing else done by that printf. And then we get to our floating point. So let's look at how we work with some floats. So we say printf, enter any value, any float value. Alright. And then on the next line after that printf, we have a scanf, and we say %f. %f of course is for floating point value, the same as %d was for integer. %f is for floating point, and then the argument is given as the same in the same format, ampersand and the variable name. So the only thing that really changes is that. Okay, so then after the scanf we have a printf again, and it says you entered. Okay, it has a couple of tab spaces there, %f/n, and then it prints out the average. So here in this case, since we just have a %f, you will see the full resolution of average, meaning up to 6 decimal places after the comma. So that's basically how you output floating point value and how you input or capture a floating point value using scanf and printf. And then let's look at the third data type. So we had 3 data types up here: int, float, and char. So with char, we're just moving the cursor once again to the next line, and then we have this funny statement here. Alright, so this is one of those statements that you'll just have to memorize for now. It's f-flush strin. Basically it just clears the keyboard buffer. Whenever you want to capture a char, just make sure your keyboard buffer is clean first. Alright, so we have printf, enter any character. So we're just telling the user enter a character. Then we have scanf again, and just like before, now we have a %c, whereas before we had a %f or a %d. Now we have %c, that's short for character, because we would like to capture and store a character from the keyboard into the char input variable. Once again, don't forget the ampersand. And then on the last line here, we're just saying you entered. Now there's something funny happening there again. %13c char input. Normally you will just have it like this, so it will just simply print out the char right there. However, if I type in a value here between the percentage and the c, not the dot value, just trying to find it, like over here we have the dot value, we're just typing a value, then that's actually in which column should it be printed on the output screen, on the console window. So at this point in time, let's build and run our code here, and let's look at the outputs. Okay, so it's saying here enter value 1. So I'm going to just type some straightforward values, 10, 20, 30. The sum total is 60, the average is 20. Enter any float value, 1.23. You entered 1.23, and as you can see, that's this output statement here, you entered, and we're not rounding the floating point value. So it's printing out all 6 decimal remainders. And then type any character, so let's say capital T, and then it says you entered capital T. Okay, so that just demonstrates how to input and output integers, floating point values, and char. And of course, in our code, we can also see how to work with variables. Alright, so that was it. That's the review and the recap of inputs and outputs and variables. And then you also have an exercise that I want you to do. Let me just quickly open that window for you. Okay, so here's the exercise. I want you to declare and initialize variables. I want you to capture and display user integer input. I want you to capture and display user floating point input, capture and display user char input, and display output. Alright, so basically I want you to do what you did before. Declare some variables, capture inputs from the user. We can make it 5 integer inputs from the user, 3 inputs, floating point inputs from the user, and 1 character from the user. And then down here, go and display it. Actually, here I'm already saying capture and display it. So you might as well here just go and capture it, and down here you can go and display it. Alright guys, that's it for this video. Thank you very much.